Are you ready to supercharge your data skills and unlock the power of Azure Databricks? Whether you are a beginner or scaling up to advanced ML and real-time data processing, this is ultimate learning path you have been waiting for. Looking to master Databricks and Spark with guidance from real industry experts, you are in right place. Today we will explore why Databricks is a go-to tool for big data and AI in 2025 and 2026 as well. The world is changing faster than ever, and behind that change is data. But for many, the dream of building a tech career feels out of reach, too complex, too uncertain, too fast moving. At Infasnow Cloud Technology, we believe in one simple idea: you deserve to be the part of this AI revolution. We are not just a training center, we are your career partner. Here you learn what companies are truly using right now, not just textbook theory, but real world tools, real time business use cases, and the exact platform that power global business today. Our mentor came straight from the industry. So you will hear not just what to learn, but why it matters and how it is used in the real jobs and the projects. We have many courses going on the niche technologies like data governance, mastering the data governance with Exxon and EDC, Microsoft Power BI data analyst training, 1 lakh fabric, again one of the very niche technology, Informatica cloud application integration, the game changer in the orchestration of REST APIs from zero to Snowflake. We also have Snowflake Zen AI technologies, IICS with Streamlits, and one of the most powerful one, Azure Unity Catalog, Databricks, Synapse Analytics, and data governance courses. So we have many courses. You can directly reach out to our class coordinator, Ms. Ria, to book the free demo classes. So in this video, we will talk about the real difference between Databricks and the Snowflake, how Spark powers everything from ETL to AI, what makes Unity Catalog, DLT pipelines, and ML workflows so revolutionary, how to deploy with Azure DevOps and automate everything. We start by breaking down Databricks architectural control planes, workspaces, clusters, and more. You will see how Spark's distributed compute engine gives Databricks its unmatched speed and scale. Next, we dive into all-purpose versus job clusters, powerful auto-scaling and auto-termination feature for cost efficiency, real-time dashboards with GenAI, how to run ML models, integrate with Power BI, and use marketplace tools like Fivetrans and Melissa. We will also explore the Unity catalog for data governance and vector search for semantic AI tasks, both game changers for modern data teams. This session is brought to you by Infasnow Cloud, the #1 institute for data engineering and cloud learning. Our trainer works at top tier IT companies and bring real world knowledge directly to you. Are you using Databricks or Snowflake right now? Comment which one and why. Which features excite you most after viewing this session? Unity Catalog, Delta Tables, Genie Dashboards, AI and ML runtimes, and let us know what next sessions you want from us on the key topics. Why are 10,000 plus companies switching to Databricks? It is not just about speed, it's about the real-time insight, machine learning pipelines, data governance, and automated data quality monitoring, all on the same platform at the same time. Join a community of future data scientists, analysts, and AI engineers making real impact across industry. From data analytics to Python to machine learning and AI, our courses go beyond basics. We teach you how to build impactful resumes and interviews and create portfolio that speak louder than degrees. Want to work independently? We show you how to thrive on freelancing platforms like Upwork, Fiverr, Freelancer, with strategies proven to help you stand out. Unlock the top career opportunities in tech, fintech, healthcare, and beyond with the power of data and AI in your hands. If this walkthrough help you get a clear picture of Databricks, smash the like button. Drop your questions in the comment. Don't forget to subscribe or for more deep dives into modern data platforms and AI tools. Want more content like this? Let us know what you want next. Delta Live Tables, Unity Catalog Demo, ML Pipelines. Ready to take the leap into the world of data AI? Enroll today and transform your future with Infasnow Cloud Technologies. Don't just learn, lead the change. Join us and turn your passion for data into powerful career. If you found value in this session, give us like, subscribe, and comment below. And if you are serious about learning from expert actually working in IT, check out Infasnow Cloud today. Link is in the description, or you can reach out to the WhatsApp group directly. communicate, book out the seats into the demo sessions. We have multiple classes and the batches running on the niche technologies. We are not entering more than 5 students per batches. So the ratio of mentor to the student is also very nicely framed up in our courses. And again, I'm saying all our mentors are working into the top niche companies, and those also like tier one companies. You can find out on our website. These all are the tier one companies where our mentors used to work. And we talk about the real business use cases, what we face, the challenges while working on the in these niche companies. We discuss about those. Our curriculums are built across what are the real-time problems that we have to crack into while working into these projects, into these uh, ETL building of the ETL pipelines and all those things. So thousands of companies are hiring for the skills you can learn today. But if you only want to start now, join Infasnow Cloud Technology and let's build your career in data, AI, and beyond. Not someday, but today. Thank you. Let's dive into the course.
So, okay, who all, okay, Simran, you were not available, right, yesterday? And Ria, you are also not available.
Yeah, yes, Kapil.
So I'm just forwarding it very speedily just to make you understand what we discussed yesterday. So we started on Azure Databricks and we understood like what is the basic architecture behind it. And then we discussed that it is basically it depends on the Spark structure. Spark is the main component behind it, and Spark is being derived from Hadoop infrastructure. So a more unified structure has been built up by Spark team, and the team that invented Spark is the team that is behind Databricks. So it's all got evolved into multiple years. So Spark was invented in the year 2009. After that, Spark architecture got stabilized, and then Databricks comes into picture. And basically, it means that when the whole concept behind all this is like if we have 10 or 20 computers and we want to utilize the power of all those 20 computer in one computer, that is the theory behind Hadoop, Spark, and all those things. So this all was invented in the year 2009 when Yahoo, Netflix, and the big streaming companies come into the picture, and they want that a single computer compute is not sufficient to process the bulk data loads. So if we want to combine multiple computers, then some kind of a infrastructure or some kind of a unified approach is required to combine the power of multiple computers in one computer. So then Spark comes into picture. The picture that you see is of Ali Godse, who was the CEO of Databricks. He is currently also CEO of Databricks, one of a very influential leader of this time and one of a very flexible leader. So he's being actively collaborating with multiple different companies nowadays. Like SAP is also saying its product at SAP Databricks, Azure Databricks, Microsoft. So all three major cloud platforms have the Databricks involved. So now the next important thing is Databricks is a first party service on Azure. This means that Azure integration is very deep with Databricks, and that is why like if we buy Databricks from Azure, it is like we are buying the product from Microsoft. All the support system, all the GCS activity that will be provided by Microsoft. So that makes it Azure Databricks, and it's a first party service on Azure. Like they are giving it Azure Databricks as the highest priority. Now going towards what is the Azure Databricks service structure. So we all see that inside the Spark engine, there were clusters. Clusters were the main component, and there are many different kind of a clusters, which we will see in these coming slides. And then workspace is the place where we can create a Jupyter style IDE notebook to write our code. Code can be supported into 4 different languages. Then we have an administrative console controls optimized Spark. Optimized Spark is 5x faster. This means that earlier when there was a Spark structure, there was a vanilla Spark which was used. And after that, optimized Spark comes into the picture, which is 5 times more powerful than the previous version. Then you can see all other things like database tables. We can also create Delta Lake, SQL Analytics to create the dashboard, ML workflows, ML flows, loads, and all those things. Self-explanatory. These all are part of Spark Unified Platform, which Databricks provide a UI to utilize all these things. Then the next thing comes, like it deeply integrates this with Azure, and on the top of that, like a new layer is coming, which is Azure Portal. So Spark Databricks got deeply integrated into Azure. So we can use the same Azure website to get the Databricks, as Raj shown that to us yesterday when we logged in into the other tool, which is the Azure Data Factory, the ETL tool. We can see that when we see the transformation data flows, we can also see Databricks notebooks there. So whatever code we can write in Databricks, that is also available into the ETL tool, Azure Databricks Factory, and can be utilized in our existing workflows. So buying Databricks directly from Microsoft, also all support will be provided by Microsoft. It's a single unified billing. So billing will also be a kind of a single billing. Like there will be no separate billing for Databricks and for the Azure Blob storage. There will be a single bill raised by Microsoft for utilizing both the services. And again, as we looked into yesterday, creating an Azure Databricks account is free account is not possible. We need to utilize our cards because uh, Databricks cluster are coming on the premium workspace. So whatever is coming on the premium workspace, it will be on the chargeable basis. Still, I will talk with the CSMs in JCI if they can provide us some space to do our POCs. So that is one. Any questions up to this part? And here you can see Azure DevOps, which is again the deployment of CI/CD. So whatever code we will write into all these things, that the DevOps is going to get deployed. So Azure DevOps is also deeply integrated with Azure Databricks. It is coming from Azure portal and then it get integrated with Databricks. So currently Databricks is, you can say it's a kind of a Hulk in the ecosystem, which is providing all possibilities that a person can think for database and analytics platform, and that is why it is gaining a topmost traction in the companies and in all the projects. And another important thing is the Unity catalog, which is again a premium feature. So that will also not come on into the standard workspace. It will also come into the premium workspace. So premium workspace and standard are the two kind of workspaces provided by Databricks. So this is one thing. So if we define Azure Databricks, it's a Spark-based unified data analytics. It's a platform as a service thing, and it is optimized with Microsoft Cloud. So now going back to the next one, creating Azure Databricks service. So as soon as we will create a Azure Databricks service, this is something which we can log in into the Azure portal and then create a resource group. After creating a resource group, we will start spinning the Databricks service. As soon as we will start spinning the Databricks service, we will come to know what is happening behind the scenes. So this is what is the Azure Databricks architecture. Earlier we looked into the Spark architecture. Now this is the Databricks architecture. Again, this Databricks architecture is divided into two main most important things. Two most important plane. One is the control plane, which is like Databricks subscription, the functionalities which all is coming to us from Databricks side. And the second one is from the Azure side, like Azure Resource Manager, the data plane. The data plane means where our data resides and where the Databricks workspace is going to create it, where the Azure Blob storage is going to get created. So as soon as we will launch this service, what will happen? Like behind the scenes, 4 resources will be automatically created. What are these 4 resources? First one will be the workspace. So here you can see a workspace will be automatically created when you launch Azure Databricks service. Second one will be a storage account will be created by default, which will be your Azure Blob storage account. What this will do, this will hold all the Databricks file system. So you can see DBFS, which is Databricks file system. This will get located inside Azure Blob storage, and what it will do, it will store all our metadata information. The same thing what in Informatica we know that when we launch our mapping, the mapping information, the metadata information, it got all loaded into data centers of Informatica. But here what will happen? It will all stored into Azure Blob storage. This storage will not be ours storage. It will be automatically created when we create a service. And then virtual networks will be created automatically. These are the virtual networks which can be created, and it can keep on increasing like auto scaling or auto stop as much as worker machines will come into the picture. And then there will be network security group, which is NSG, that is also created. So these four will automatically created up once we launch the service. So the most important takeaway again here is our data always resides and passed in all our subscriptions, and we have a full control over it. So again, the data will be with us. Only the metadata informations and the other information will be inside the Azure, but the whole thing will be with us. Even in this case, our metadata will also be with us. So that is a good thing. With Databricks, like we can go and check it, like all things will be on our Azure blob storage kind of thing. So this is the Azure Databricks structure. Then most important thing is the clusters. So as soon as Databricks workspace is launched, 4 resources are going to get created. And the most important thing which we will see inside the Databricks will be notebooks, the jobs which we will run, the models which can be deployed, ML workloads, the data which is our data, and the clusters which will start spinning up in 5 to 6 minutes of time. So how many different types of Databricks cluster are and what are required? So first of all, we need to understand what is Databricks cluster, how many different types of cluster are there, what is the configuration that we can pass on to each cluster. Creating a cluster, then we will look into the pricing, cost control, and cluster pools. So cluster pools are basically required to reduce the cluster time. As I mentioned, like each cluster is going to take 5 to 6 minutes, depending upon the kind of a VM allocated to it. So if we are building up a small cluster, there are some features where we can input like, okay, we only need 1 or 2 VMs. So the cluster time can be optimized from here. Cluster policy is used for the user experience, like on which cluster we have to give the full access to the whole team, or who all is going to get restricted on some of the clusters. So kind of a cluster policy that is being created inside it. So now looking into the Databricks cluster, this was very well explained by Raj yesterday. Like there will be one driver node and the worker node. This all is being inherited from the Spark architecture. So Spark and Hadoop knows how to work on that, like multiple computers to get the power into one computer. That is all. So workers are nothing but a multiple computer machines which are collectively getting the power to the driver node. So basically, driver node is responsible for orchestrating all the worker nodes. How many worker nodes will be required? What are the tasks assigned to each worker node, and what is the completion after completion of the task? The output result will be sent back to the driver node, which is going to get published into the workloads. So driver is basically responsible for orchestrating of all the worker nodes. So in this, like ETL for the data engineering and data science and machine learning workloads. So these are two important kinds of workloads. Those are being run on these kind of a Databricks cluster. One is the ETL pipelines, which we will be creating, which are like data engineers are going to get create. Another one is data science and machine learning workloads. So now looking into the cluster types. So there are basically 2 types of cluster. One is all-purpose cluster. Another one is the job cluster. So what are all-purpose cluster? All-purpose cluster can be created from GUI, like the UI of Azure portal or the Databricks portal. They can also be created from CLI interfaces, like our command prompt kind of thing, which is like Azure CLI we have seen inside the Azure portal, and those can also be created from API. Like there are 3 ways to create a all-purpose clusters. So they can be manually created, but these can be created by jobs. Job cluster means your job is running. You created an ETL pipeline on Azure Databricks. Now, once your job is running, you can the job cluster will be automatically created. So those clusters are responsible for running your jobs, and these clusters can be manually created. They can be terminated and restart at any point of time. So you can give it like after 3 minutes, my cluster should be stop if the files are not coming or something like that. At any point of time, we can terminate them and restart them. That is not possible with the job cluster. Job cluster will terminate once your job is going to get end. Suitable for interactive workloads, like we are running any kind of an ad hoc pipeline, we are running it. So all purpose clusters will be utilized, shared among many user for collaborative purpose. Like if we want like kind of a, we want to give a cluster to multiple teams, we can give it. But these clusters are isolated in nature since it is responsible for one or single pipeline. When jobs are scheduled, jobs are running, then only these clusters comes into picture. These are cheaper to run, these are expensive to run. And interactive analysis and ad hoc work is main purpose of all purpose cluster, mainly like data analysis things and all whatever things like ETL pipelines and the machine learning workloads, all those will be created on all purpose clusters. So, and the repeated production work will be done on the job clusters. Cluster will run till the job run and destroyed as the job finished. And these clusters take 5 to 6 minutes to spin. To speed up, there are the another functionality cluster pool, which we will look into further sessions. Cluster policies to keep cluster under control. So these here we will, the key takeaways are just a two type of cluster, all purpose job clusters. That is all what we learned from here and what all components are inside the workspaces. Then, as we discussed, like when we start creating a cluster, there will be several kind of a configuration that we have to provide on Azure Databricks portal or Databricks portal itself. So these are the kind of a configuration that we will provide. Whether those cluster will be single node cluster or multi-node cluster. Multi-node explanatory like one driver with one or more workers. So the Spark jobs where large workloads are there, those will be responsible for running on the multi-nodes. So when we choose all-purpose cluster, let's say, and we will enter the configuration that we want to run a very large job, we will say that keep it on the multi-node kind of a configuration. And if we want that, okay, we only need to run data analysis or a very lightweight ML or kind of a workload which does not require distributed computed capacity, we will run it on the single node kind of thing. Like there will be only one driver node and no worker node will be on your single node clusters. So these are not suitable for large ETL, but these are suitable only for doing kind of some kind of a data analysis. So let's say we have one of a CSV file. We want to just create a small data frame into it and want to check like what are the patterns into that data. So maybe it consists of 50,000 record. We just want to do a quick analysis on that data frame. Then we will create a single node kind of a cluster to do lightweight kind of a data analysis. Multi-node clusters basically horizontally scale up the cluster. So in multi-node, what will happen? Like it has one driver and one or more worker node. But if you want to increase, as soon as we will increase more nodes, the workload is going to get horizontally scaled up. Now the second type of cluster configuration, this is the first option that we have to give. Second option that we will enter is access mode. So there are four different type of access mode inside each cluster. First one will be the single user where only one user can access it and it supports all four type of languages. The second one is the shared kind of a mode where multiple user can access it. So if we are saying that our all-purpose cluster is the shared cluster, it can be utilized into multiple different workspaces. So let's say for UK Mentor, we create one workspace, which is UK Mentor workspace. For BSNA, we create another workspace, which is BSNA workspace. Now we created a shared all-purpose cluster. This means that this cluster can be called inside both the workspaces. But if it's a single user, it will be specific to that particular workspace. Now, this feature is only available into premium workspace and is not part of a standard workspace. And it supports only two languages. One is the Python and one is the SQL workload. Java and R is not supported here. Then the no isolation shared. This means that it will not be shared and it will not be no isolation. Like if failure in one process will happen, it will affect the other processes also. It will become less secure. Multiple users can access it, but it only supports all four types of language: Python, SQL, Scala, and R. and it is available inside both standard and premium workspace. Only difference is it is the failure of one process is going to get affect the other processes also, and it is less secure because there is no isolation. Here there is a process isolation, like one process is failing, the other will not be impacted into the shared one, and all the environments are also isolated. The custom can be created using the legacy configurations. These are custom access mode. So in the custom access mode, we can fill up this information. These are less popular. So the most commonly used are the shared one and the single user one. So these are the different type of access mode. Then coming up to the Databricks runtime. This is again similar to what Informatica runtime environment is. Databricks supports 4 different type of runtime environments. First is the Databricks runtime environment, which is of its own runtime environment where it supports Spark. It supports this Scala, Java, Python, and R libraries. It also supports Ubuntu libraries, GPU libraries, and data lake libraries. Like all these libraries are supported inside Databricks runtime environment. And the other Databricks services are used to run notebooks, jobs, and the clusters. So basically, it's a group of all standard libraries that Databricks runtime is providing us. Then the second kind of a runtime is which we have to choose from 4 of these runtime. We have to choose like which on which runtime we want to run our workloads. Second runtime is runtime ML, most popular with the very highly specific machine learning libraries, which are PyTorch, TensorFlow, XGBoost. So these are all machine learning libraries. So it will give us Databricks runtime libraries plus these libraries. So the above libraries will also come into this one, and along with that, we will get PyTorch, Keras, and other libraries. Everything from Databricks runtime will come plus these libraries. Then the third kind of is Photon runtime, which is used to everything from Databricks runtime along with the Photon engine. And the last one is Databricks Runtime Lightweight, which is a runtime option only for the jobs that don't require any kind of an advanced feature like automated workload where performance optimization, auto scaling. So let's say we have created some kind of an ETL job. Now we want to do a performance optimization for that job. Then in those cases, we can use Databricks Runtime Lite. It is something very similar to Informatica Cloud Runtime. So sometimes we can run our jobs on cloud runtime environment. This is the same kind of a functionality. And it's not requiring auto scaling, reliability, and improved performances. Like just to optimize the things, it will be there. Then there is the fourth option, which is auto termination. Like once the cluster is idle, or the ad hoc clusters, or some clusters which we are running on evening time or in the night time. So we can put functionality called auto terminate. After X minutes, the cluster is going to automatically terminate. Default value for single node and standard cluster is 120 minutes. So 120 minute is the default setting when we start up the cluster. This is the default value, and we can specify a value from 10 minutes to 10,000 minutes as the duration for auto termination. Next setting will be auto scaling. So auto scaling will be add or remove nodes from the cluster. So user specify minimum and maximum worker nodes which will be used for that cluster. Auto scale between minimum and maximum load based on the workloads, and not recommended for the streaming workload. This is an important point here, because streaming workloads, we don't know how much they can stream up, and if we select streaming workload as auto scaling, it will charge too much of cost and it can go up to many clusters. So it was not recommended to use streaming workloads with auto scaling functionality. So whenever we are using Apache Kafka or some other services, we will deselect, or we will say that this option we will not choose auto scaling. So that is all from my side on the cluster configurations and overview of the Databricks cluster and Azure Databricks architecture. Raj, you can continue on the practical sides of it.
Yes. So just one point, Kapil, to add here on the Azure Databricks side. So when creating the Azure workspace, we need to define the resource group first. So what
Yes.
we need to do there, we need to give this virtual networks and where it will store the data and those kind of things. If we'll not share these things, then it will create on by default. But if we want some custom things, we need to define those before creating the main workspace in Azure portal.
Yes.
So I'll share my screen. So I also just give some like high level things on these points which we covered yesterday, like almost half of them. So Spark, as Kapil explained, Spark is the main distributed computing engine which is used by Databricks to like scale up their computational power using the distributed thing. So the second thing is for the warehouses. Kapil explained all things about the clusters, how they are working, and there is similar thing like clusters is a warehouse, but it usually supports to the SQL scripting mostly for the analysis purpose, because it don't have that much capability what clusters have, because you saw that we have a lot of things to customize here in the clusters for high level task, for low level task, but that is not here. We just have limited options. So mostly this will be used for analysis and BI reporting kind of things. And clusters, we know that it is a high level compute engine which we can configure for our use. Then second thing is notebook. Notebook is same like what we saw in the Snowflake also, where we will write our complete code. Okay. So under this workspace, let's suppose if I go to any of the folder. So this workspace is giving us the repository where we can store and we can do everything like the scripts and everything. So notebooks are used for the scripting, same for the SQL queries and catalog. So now catalog is the database system. So here you can see all the data we can store. We can retrieve the data from here to our notebooks. We can ingest the data from other sources to this main data repository, and which is being performed on some of the like Azure S3 bucket or sorry, Amazon S3 bucket or Azure Blob Storage, something like that. After that, we saw that for connections, for extract connections, we can create some custom folders and there we can run the queries. Okay. So let's go to the dashboards this time, because it is one of the most interactive thing they have implemented here with some help of this Genie. You can see this Genie is here, which is kind of the AI bot for us, which will help us to create some dashboards here. Okay. So we will go through these dashboards first. Let's create one dashboard. In the previous account, I have created that, but right now it is not working. So we need to do this manually here. But I'll just show one thing. So for our this thing, we will use this dedupe output file. Okay. We took this dedupe output file. It will do everything automatically. So let it get started. Okay. So it is started right now. It will show some results and everything. That is a normal thing. If you go to the canvas, now they have given these many things here to add visualization, add a text box or a filter. So let's suppose we will go to the visualization. We'll just create one thing here. Okay. So now you can see the Genie is asking us the question like what we need. So let's suppose what we will say, from this data create a pie chart for duplicates using customer name. If we will give this command to this Genie, it will give some result first. Okay, and he will ask, is it what you want or something else you need. So we can accept or reject. For now, let's accept this thing. So here we can see the pie chart they have created. If you see the data, it have mostly this name, something like that, and some of them are different like this one. So you can see that's why this pie chart is looking like this. Some values are here and all those are same customer. So this is the use of this Genie and the dashboard combination. And if you just think about the profiling and the data quality, then these are really helpful for us because we don't need the actual coding here. Or else if we have the experience on BI, let's suppose Simran or Triana they have, so they can create those things here directly on this thing also. Let's suppose bar they want to see a cluster ID for the X and for Y cluster size. Not cluster size. Let's take something else. Address line one. So this is how we will get all the visualization for the data. So this is the great use I can see. Any questions or any suggestions on this thing? Like you can explore this thing. There are a lot of things. I just explored this capability, like what we can do using the Genie and the dashboards. One of the
Yeah,
best combination in Databricks.
yeah. And we can also create the resources in this dashboard, Raj. I think the resource group, the clusters that we are creating, we can create, those can also be highlighted into these tiles, one
Yes,
by one, by two tiles. So, and then
yes.
we can allow whole team to come up to this space. So if let's say we are creating one of the projects, so this dashboard was also explained in the Azure portal, Azure Databricks portal. And then we can say that, okay, this is our workspace, like this is for our project where we can assign all kind of resources, all nodes, whatever we are creating. Resources means our Azure blob storages, our other resources that we will start using in when we launch the Azure Data Factory. So whatever things that we create, we call them as a resources, and those are all bind by a resource group. So those all can be visually available into this space, this canvas.
Yesterday I downloaded one of them. It was not there, I guess. But we can download these dashboards in the PDF or any other format if you want. You need to publish this thing and then you can download this. This one is not available, I think, for the free account. But yeah, the self publishing we can do. And once that is done, okay, yeah, it will publish it in some time. So after that is done, we can download this thing in PDF format also, and we can use that one. So those are the things in dashboards we can see using the Genie. After that, pipelines and workflows. Yesterday we saw this thing, pipelines and workflows. Pipelines are mainly the orchestration tools only, but we can use it as a mapping task or task flow also. But let's suppose you have critical thing like for customer master, we have a lot of mappings for extraction only, then lot of mappings for integration. So what we are doing, we are creating two task flows there in customer master. So instead of that, what we can do, we can create one task flow in this pipeline, okay, and another task flow in another second pipeline. Okay, once those two pipelines are ready, we can orchestrate those two major pipelines. Like those are for now for us, those are like task flows. But if we see this orchestration job, we can orchestrate those complete task flows in a way like first one is done, then go for the second, then go for the third. So it will be like we can run the major jobs like very high level scripting, high level scripts or very long codes we can run easily in the orchestrated flow. With this thing, they are providing us some parameterization also. So right now we are not completely aware of how these parameters will work, but yeah, we can explore on this. Once these parameters are done with us, we can do the same exercise what we are doing in our mapping task. So we can easily, without going to the code every time, we can change those parameters and run those things. Okay, so these are the thing. 10 TLTs. Okay, so yesterday what I showed there, those are not actually the DLTs. I tried a lot to create the DLT, but it is not getting created. If you see this thing, this is the materialized view actually. So what is materialized view? It is kind of a updated version of a simple table. So what it will give us? It will give us the computed query results. Like once you run one query on this thing, it will store that results, or it will store those computations in this in the metadata, not metadata, in the background of this tables. And for the next time, whenever we will query this thing, it will give us the outputs very easily without doing the too much computations. So that is what these materialized views are used for in all the things, like not in only Databricks, for all over. Let's suppose in SQL databases also we have materialized views. They will also do the same thing. They will store the computations whatever they have done on the first querying, and after that they will use those outputs. So DLT is the delta live tables. I have some kind of comparison in between the normal tables and those. We saw this yesterday, like data quality dashboards, some management related things, orchestrations. Those things are available here, but we are unable to do the live hands on this thing because of the free account. We are unable to create. We saw. I tried to create this from multiple ways. Like here we have only pipeline. I created with the DLT pipeline, but still it is not working. So let's see how it goes if we get the premium. Okay, then this data quality dashboards, they are saying like it is available for DLT only, but I can see we can do this thing on all the tables. On let's suppose this is the normal table, and if you see, I have created one dashboard for this. So these that dashboards are really automatic. We don't need to do anything. We just need to click generate the dashboard, and it will give all the analysis from their side only. So I don't think this will be helpful in the business use cases, but still it will be helpful for us to understand uh, the history of data, like how it went from Mach 1 to 3, 4, 5, that kind of things. These are the data quality dashboards. And now let's go to the BI connections. Okay, so what is one of the best thing Databricks provides is the connections, and this is also one of the best thing they are providing, because if you go to any data table, let's suppose this is the one we chose, you can directly share this data in any of them. You just need to create the connection to establish this data directly into the Power BI. You can download this connection file if we have that possibility to create the direct connection using this downloaded file, or else if you open this file we will get some credentials there. So using that credentials also, we can connect to that database directly to the Power BI. Or we have one more option is for the Tableau. That is one of the best thing we are getting in the Databricks. So this option also, we saw this thing, data quality dashboards also. There is one more option as a volume. Okay, so in simple terms, what is volume? Volume is a simplified or the small version of data lakes. Okay, so we know that tables, water tables, if you come here, if you just see the sample data, it will be a structured data. You can see like they are giving the headers, then some rows in those, but we don't have any image in this thing. But what data lakes are meant to be do, they are there to store all kind of data. They can store images also, they can store tables also, they can store CSV files also. So that same capability they are also given to us. So you can see this upload to volume option. So here we can create one volume, okay, and there we can store over all the files, okay. And now the second question is like, if we have all kind of files in that volume, so where we will use this? So actually for our use case it is not important part, but if we come to the machine learning, there we need this kind of structures. So this neural networks or the algorithms which we are performing for the machine learnings, they need these kind of things, like some PDFs in that, some CSVs. We can directly point towards those CSV or those PDFs to train or test our ML models, machine learning models. So this is not an important thing from our perspective, but yes, still this is a great functionality they are providing to store all kind of data. Okay, after that let's go to the alerts. Okay. So alerts, they are providing us for the SQL scripts. So what does they do? So basically alert is there for the scheduling. We can schedule the emails, the notifications, all those things using the alerts. So for them we need to write some scripts how we can schedule those things. I was unable to find those things in the UI, like we cannot do this uh, scheduling thing in the UI, but we need to write the codes for this alerts. But they are like same. We can share the notifications or the schedules using this alert. But if we need to schedule something, let's suppose we have data which will come at around 9 p.m. Okay, and at that 9 p.m. we need to run the pipeline. So those schedules we can get in the pipelines only. Okay, so let's suppose this is the D2 pipeline, and here is the schedule. So that schedule we can add here. So when we need to do what all things or notifications, those are the options they are providing to us. Like at what time we need to schedule it. So it is automatic thing. And if you remember that Kapil mentioned one thing about the streaming of the data. He mentioned that for streaming data we don't need the clusters, or auto scaling or auto stop of the clusters, because those streaming data, if we want to schedule them, we can schedule those jobs also, streaming jobs. But how they work? Let's suppose in your database the entries are getting like continuously. You have one database there, you are getting all the entries one by one. Let's suppose right now we got one record. After some 2 3 seconds one record. So those pipelines we cannot do batch. We can do, but if the business case is not like that, then we will use the streaming on those. Okay. And in that streaming jobs also we have the schedule option. So it depends on the business case completely when we need to use, but just for the insights we have these kind of functionalities to automate our process, to reduce the manual interventions. Okay, so we saw these pipelines also and orchestrations using the jobs we saw. Now the thing is, like yesterday we discussed that whatever notebooks we are creating. Okay, so we saw this thing in the workspace. You can see the notebook. If you want to create new, you can create from here. But let's suppose this is the notebook we have created. Let's suppose this is D2 test Python, and if you want to use this in Azure Data Factory. So if this Databricks is hosted on the Azure workspace, then we can directly call this notebook here. Okay, and we can orchestrate this thing. So that is the functionality they are providing. And after that, market support. Okay, so yeah, Kapil, we are currently going with the one marketplace utility for the TransUnion. So same
Hmm.
kind of things we are getting here, not the same utilities, but different kind of things we will get, such as Melissa is one of the thing I know that they have the address verifier, better address verifier, Melissa. I'm not completely sure,
Okay.
but
Dinesh was
that
mentioning some name, right, Raj? Like he was he was mentioning Melissa or something. Okay.
uh, I'm not sure completely,
Hmm.
but yeah, they have provided these many sections. Let's suppose uh,
Click on demographics,
where
go up. There is a demographic.
demographic.
Okay. No utilities there.
No, no,
And
no, no. There
category.
are yeah, these are the demographics. Geolocate. Let's suppose if we what are those? I'll just explain. So these are the utilities which are created by the third party companies such as TransUnion or any other companies. They will create their models and they will host those on this marketplace for the companies like Databricks or Snowflake, and we can get those models pre-built and we can use directly into the Databricks for our use. So it is like the bundles what we will get in IICS. This is the same kind of thing. So yeah, Kapil, you were
Search
saying
for
something.
Google Maps API. Is it there? Google Maps API.
And one thing, Raj, in this marketplace, we can even publish our products.
Yes,
Suppose we
we
come
can
up with
publish.
some POCs, we can publish them here.
Yes, we can publish those.
Or
So for
search
that
here.
one,
Right,
what?
Melissa is the popular one. I checked on ChatGPT. It's saying Melissa data is the popularest for address verifier. Melissa.
MELISS. I think we need to select one of them. Like I yesterday searched this thing because their filter is not working correctly. If you do this thing, it will show some of the results, but without them, it will not. Nah.
Okay,
Melissa, I think it is not hosted on Databricks.
okay, we can search. And the most popular one is the five trends, which even JCI is looking for that. So five trends is also good thing where they are supporting with the external connectors.
Yes, data store, Google Maps. Now we need to check on this thing, like how this thing provide land and water features. Okay, we need to check how we can search those things and whatever are available on the Databricks marketplace because
Mm.
these are really great utilities because
We
a
can
lot
create
of
a
things are getting resolved.
business use case. So we will say that, okay, we are again running the address verifier on Databricks. So now we need Databricks account.
Yes,
So analytics team will be looking like they are doing address verifier everywhere. Snowflake, Databricks, Informatica, they are behind that.
we want the result, no matter how it will get, how we will get it. So yeah, this is the marketplace. Uh, After that, we have one functionality here as a vector search. Okay, so Kapil, you are aware of the Cortex search in the Snowflake.
Yeah.
So it will do the same kind of thing. If you go to the compute and we have this vector search, I think we cannot create it right now. Uh, so what it will do, let's suppose you have a big data and in that data set or in that whatever if it is a volume or it is a data materialized view, whatever it is, you need to search something. So you can use this vector search. What it will give, let's suppose there is a Raj is the name, and if I search RA, it will give the Raj. So what it will do, it will give some nearby values also with that. So it will be easy to search the things which are not, like, we don't know the complete spellings or the complete names of those things, but we need those things. We can use this vector search. Actually, it have some more applications also, but still not aware of those. But yeah, we can use this vector search for these kind of things like near values. If you want
Near
to
vector and
search something,
semantic
it will give.
search,
Yes.
ML, and large language model. So all these are related to that AI thing. But yeah,
Yes.
it's a same component is available on both the sides. Vector search in Databricks and vector search in Snowflake using
Cortex
Cortex.
search. Cortex, I think.
Yeah, we are calling
Yes.
it Cortex.
Yes. So that is the thing. Yeah, and after that we have this app creation support. So if you see, there is one app thing here. You can create the app which you can host on the Databricks server only. Okay, you can host it on Databricks server. If you want to host it using any other platform, you can host that thing also. But what it will do, let's suppose we want to create a live dashboard which will reflect the system's stability or anything like that. We can create this app. Okay? So simple thing. Let's suppose we will create this hello world. You don't need to do anything. You just need to install this thing. This is the, what we can say, boilerplate, the pre-built applications they have given. So it will take some time to deploy. Once it's deployed, if you open this app, let me check. Do we have that available here? Oh, it's just stopped. So it will be a real-time dashboard, we can say. Or let's suppose we need some user input. Okay? If you need any user input or critical things to be done on the UI, but they are the business users. They don't know the technical things. So we can create the simple dashboards using this Databricks, which are hosted on Databricks and which will use the databases which are here in the Databricks, but they will show the results on UI. So this is a really good case, good use case for the business users who don't know the technical things much, but they can still do the data analysis or visualization of data using our applications. The scale is not like we have the very good scale here for creating, but still using all these functionalities. Let's suppose Firebase is there, Flask is there. Using those things, we can create the apps. And using Flask, I know that we can create interactive applications, web applications. So yeah,
Right.
those are
It
Streamlit
is,
those
is
are
also, yeah.
yeah,
yes,
similar to Streamlit.
And Lukman, you presented one session, and I believe you created an app on Streamlit in
Yes,
Snowflake
Kapil.
session, right? Mhm.
Yes, yes.
So this means, let's say we create some dashboard, and then we can publish those dashboard as an app, right? And then those app can be run on mobile devices.
But Kapil, while creating that, there were some machine learning codes that were written in
Hmm.
Streamlit as part of training. So I
Hmm.
had considered those sample codes that they had written, the training models, and then I
Hmm.
had created that. So I
Okay.
think, Raj, here also there could be such code required. Yeah, if it is about creating a dashboard, we can do that. But passing an input and expecting to get an output, customized output, for that, I think we need to
yes,
train
we
models.
need. Yes, we need to train the models. Not like model, we need to create the app in actual.
Hmm.
Uh, those models will be at the back end if we need any special utilities on those apps. Yeah, we can train those models, but to create the apps, we need the actual skills to create app using those additional tools like Flask. There we need some coding also. So we can create and use define apps for the business, for reconciliation, for analysis. All these things will be get covered into the app creation. Okay, and after that we have this GitHub. So GitHub, yesterday I shown this thing that how I configured the GitHub with the Databricks, and right now this symbol you can see on this folder, that is for the Git, and it is saying like this folder is under the Git versions. Okay, so whatever I will do here, I can push my code on the Git, and if someone else is doing, uh, let's suppose here we have this additional thing here which I created, this completely new pipeline. Okay, so if I push this code with some message, it will reflect in GitHub, my GitHub account which I created. And once it is pushed, let's suppose this is the second account I was using, so I will get the notification that someone has pushed the code into the GitHub. If you want to align that code with your code, you can accept, or else we can comment on that, like these are not the things we need, we can roll back this thing. So those kind of things we can do using the Git versioning. After that, Unity catalog, we know that right now we don't have this utility because of the free version, but
This is
Unity catalog
premium
is one of
workspace.
the, yes, Unity Catalog is one of the premium feature which Databricks is providing, and that is making Databricks to stand out from all the competition, because we are getting a single platform where we can monitor everything. Everything means these pipelines also, these worksheets also, the runs, how many runs we have on these pipelines, or how many queries we have run, what is the DBUs, like Databricks units we have consumed. All those kind of things we can monitor or govern using the Unity catalog. One of the best thing in the Databricks, because it is giving a functionality which can handle all the flows on a single screen. That is the main thing, because we don't need to go in every place. Like in job runs, I'm coming here and I'm seeing how many runs are there. Okay, this was on the Thursday, today also we did some run. So what changed? Did this data set changed, or this table is changed, or what? We need to do everything manually, but this Unity catalog is giving us the power to monitor all these things in a single console, we can say. And
Kind of
after
a
that,
data governance thing, which can provide line lineages also. So Unity Catalog
yes,
is providing lineages, security, permission on files, tables, views. This is something similar to what Informatica Exxon and EDC provided. So the
yes,
combination
Exxon.
of Exxon and EDC is inside Unity Catalog. So yeah, Raj,
You
you're thinking correctly. Like one of the key thing which is making Databricks popular is Unity Catalog. The second best thing is those DLT live table. So that is
yes,
also a very unique thing which they are providing. Where two things are happening up. Like data quality rules are already coming up in our pipelines automatically, like without
yes,
too much time on writing up the data quality rules. DLT pipelines are automatically taking care of that. And another important thing, what is happening is without taking care, governance is automatically coming through Unity Catalog.
exactly.
So, yeah. So there is less, more kind of an automation on two things, data quality and data governance.
Yes,
Okay, you can.
exactly. Actually, they choose the best engine to do the performance, which is Spark engine. That is the first thing. Second thing, they provided something like DLTs, pipelines, the orchestration, then workspace which can handle the Spark, Python, SQL, R, Scala, Java, all those things. Then these catalogs which are separated from the compute, and the compute where we have two things, cluster and warehouses, which are giving separate power for our high level computing and the analytics. Those are the key things which are standing out for the Databricks.
Covered all four languages. I think all the languages are covered. Most important one,
Yes,
SQL, Scala, R, and Python. All popular libraries are covered, which are like high-level libraries. Everything is covered.
yes,
Those libraries we can import inside the notebooks. So those functionalities are also covered. I think everything they have covered, like nothing is unturned in this ecosystem. Uh,
Yes, almost everything.
and on the meta store, the last point, this meta store is related to creating tables, right? And the
So
database.
what is Metastore? Let's suppose we are creating this table schema, okay, this database schema, all these tables. So whenever you are creating something in the data related side, like storage side, it will create some metadata which are getting stored on this Metastore. Okay, so what it will do? Let's suppose we have multiple tables and we need to interact with them. So what Metastore will do? It will have all the schemas on a single page, on the metadata on the single page, and that will help us to lineage, create the lineage in between all the data sets. So what metastore is doing, it is storing all the metadata of all the things which are coming under the data related files, and it will help into the lineage purpose. So
Correct.
what is another better thing they have? This
Mm,
lineage in everything.
oh,
Like they have where from where data is coming, where it is getting stored, what is using that, and due to this thing, I know that due to these things, Unity Catalog is the best
correct.
innovation they found out
Mm,
due to
mm,
these
okay.
lineages.
Something like all the you are saying all metadata description or all the metadata information
Yes,
is stored in one schema, and through that schema, they are providing us functionality of lineage in Unity catalog, and it's kind of a box full of data files and the metadata column names. That like one
yes,
document created for Mentor, where we put all the data metadata information, so that once the project will start, we can look out for every information at
yes,
one place. Something
yes,
similar is happening in this my schema. And this information schema is automatically created when the database has been established, right? The
yes,
information.
yes. One more thing in Metastore, Kapil, what is happening? Let's suppose sometimes we will delete one column from this table.
Yes.
So after that, we need the history back, or we need some inputs on that deleted column. That thing Metastore will give us, and at the back end, when we are saying like time travel, we can go
Yeah.
to the previous
Correct.
version.
Those
That is
those
also done by
information
the
will not be
Metastore only.
deleted to Metastore. You are saying if a column is deleted, even its audit trail has been preserved in this space.
Yes,
Uh,
yes, everything. Like I have one tab here for the thing. Wait, all functionality here. Okay, so these are the key things which Databricks is providing to us. Time travel, you can query the previous version. Data versioning, create new version on every write. This is the thing what I'm saying. If we write something on the that table, so what was the previous schema? And that question got resolved by the Metastore, and DLTs are resolving the versioning issue also. Like they are storing the previous data. I'm not sure the complete duration of that storing, but somewhere I found it as 90 days. They will
okay.
store the
Mm.
previous versions. And automatic schema adaptation. This thing is really good in DLTs. Like we don't need to define the tables first. We can write the complete code, complete logic, and after that, whatever columns are coming there, those are getting automatically created as the DLT tables. So that is really good thing, because I know in the previous experience, I know whenever we need to do something on the tables, we need to first create the table, and we need to define all the things like whatever columns are there, what is the description of that column, the
Mm.
metadata of that column, like is it a string, is it a float, is it an integer. But these things are automatically getting checked by the DLT tables, and they are getting automatically created. So that is one of the best thing. Then change data feed again, for the versioning. They are keeping all the tracks from this version to this version, what is happened, how to what all things are changed there, and we can go back to the previous version. These are the interrelated things, you can say. Then audit history, again DLT have this one also. we can store all the audit history. I'm not completely sure what kind of history it is storing, but previously I saw that for error records, errors, we are getting one simple another view where we can check all the errors, like due to what we are getting these errors and failures. While doing this complete thing, I saw one thing very good in the scripts, that when something is failing, they are giving us a very brief and very easy a very easy description for that error. Like by just reading that error, I'm getting like what I'm doing wrong. So
Okay.
maybe they are using some AI capabilities in that. Mostly in pipelines, you can see if you go to any pipeline, this Spark. If I run this thing and it will get failed somewhere, it will go all these things. So right now, no error. Like I just copy pasted the previous data here, previous code here, so it is not having any error. But you can see these are the things, like what all things I done yesterday. So it will store all the logs. Maybe if we will run it today, it will add some data on the today's history also. So this is how it is keeping the logs. That is also one of the best thing. Data vacuuming, that retain and clean up the data. There is one thing where we can roll out all the old records. Okay, so if we will just query on the DLTs, like we don't need the data from last 160 days, before 160 days, whatever is there, it will perform that thing on the DLT very easily. We don't need to do everything in the scripts. We just need to give the commands there. So that is also the functionality there. Then you explain this concurrency control, asset transaction supports. Those things are in the screen when we are doing something with the transactions, maybe the sensitive data like bank transactions or medical things. Those are the things. Then table cloning. This is we saw in Snowflake also. Like most of the things we saw in Snowflake also, how we can do these things. And this is also the same thing for the data versioning, rollback and restore. We can choose the version, whatever version we need, and we can take the data from that version. So these are the functionality they are providing. Yeah, so this is what I found out throughout the complete exploration on the Databricks. Only the thing is, like, we need to do some uh, practice, or we need to understand the concepts
Completely.
of Spark programming.
So we can check on that, but
That is the
only
only critical thing I can see here.
the one hurdle that we all are facing is the environment. So we need some environment where you can do some practice on it. But yeah, this is a
Yes.
good presentation, and mostly like both this Databricks and Snowflake are uh, into the same spaces. But I believe like looking into these presentations, it feels like Databricks is speeding up things and it's taking up more pace. But if we learn one technology, we are also learning the other
Yes.
one. Like both concepts and all the things are same.
Yeah, and
So
there is a lot of symmetry between Databricks and Snowflake, Kapil.
yeah, only
You
difference
can
that I
see.
notice is like Snowflake is still promoting SQL analytics kind of thing, which and Databricks is going on the top of it. Like it's saying, okay, take Python, Spark, and the Spark engine, of course, is most good engine which is coming up over here. So I believe that like both of them are getting up traction, but The future is more with Databricks because it is backing up by Microsoft ecosystem. The Azure power is also with Databricks. So that is one of the most important thing which is giving it more traction. So I was just looking at the market momentum. Both are valued at like $43 billion. Like this is a Databricks valuation right now. Snowflake is on 60 billion, but revenue growth, if we see, so Databricks has been growth 70% year on year basis, while Snowflake is still 30%. 10,000 plus organization are using Databricks. Snowflake is 9,000 organization. So Databricks is outpacing Snowflake in AI, ML, and enterprise innovations.
You can see
Okay.
these are the key like high level differences in between the Databricks
Yeah.
and Snowflake.
What it provide here with Unity catalogs, like Databricks is providing governance across organization using Unity catalogs. Snowflake is providing it using secure data sharing. So they have also created one new product, secure data sharing for governance. But other
Yes.
than that, yeah, it's good. Like if we will learn this one or Snowflake, it's the choice. But parallelly, in both the areas, we will get more skills, more hands-on, and more tools. The good thing about Snowflake is they are easily giving us the free account where Databricks has lots of restriction around it.
Yes. Only thing is like
Okay.
it will give the power of Azure also. That is the key thing which is
Yeah,
making
power of
Databricks.
Azure, and what it is saying is like advanced ML deployment model capability that is with Databricks. So if
Yes.
because more and more organization are now what they are creating is their own LLMs, lightweight LLMs and agentic AI and all those things are like part of AI, part of organization. So in that area, Databricks is getting up more traction. It's more kind of a machine learning specific. And again, the next important thing is streaming. So for if someone is choosing it for streaming, Databricks is a clear winner, like real-time streaming, which is coming from IoT devices. And IoT industry is also getting lots of traction. Too many data are being generated. Like nowadays, all the devices are IoT devices. The future is like that. So yeah, it's fine. Like anyways, we if we are learning Databricks or Snowflake, we are on right track.
Yeah.
Okay, Raj,
So
thanks a
maybe
lot.
next
Just,
time sometime we can go through this machine learning models. Those are
mm.
also easy things like to